to the September 21st edition. This would be the fall equinox edition of the VLabForum. This is Steve Smith, director of the VLab, and we're coming to you live from the VLabForum studios here in beautiful Silver Spring, Maryland. Joining me is, along with our speakers, is John Chattel, our production manager, who will be handling the GoToMeeting and other logistics. Remind everyone that these talks are recorded and will be uploaded shortly after the conclusion of today's session. The format is 30 minutes more or less for content, and we follow up with question and answers, about 30 minutes there. So if you have a question, please use the raise your hand feature of the GoToMeeting or the chat function if you'd like John to relay your question that way. When we do the raise your hand, we'll unmute you and you can ask your question directly to the speakers. So today we have Dan Barrie and Heather Archambault from OER's Climate Program Office, the Modeling, Analysis, Predictions, and Projections Program, or MAP. And the topic they're going to be speaking about is testing the multi-model ensemble systems for predictions on weeks to season. So this is obviously a very interesting and hot topic. Our focus here in the VLab is on research and development transitions to operations, so we're very interested to hear that aspect of this particular project. So without further ado, take it away.
Okay, great. Thank you, Steve, and thanks, John, for the invite. So the way we're going to do this presentation, I'm going to start off, and then we're going to tag team, and Heather's going to cover the NMME project, and then I'll bring it up in the back end and talk a little bit about a new experiment that we just started funding. So a little bit first about who we are and where we come from, just to orient. So we are in the Climate Program Office, as Steve mentioned. Climate Program Office is in the Office of Oceanic and Atmospheric Research. And CPO is principally focused on funding competitive research projects. So we issue, a large part of our activity is to issue an annual call for proposals across a number of different programs within the office. We have our program, which is focused on modeling and prediction. There's a program focused on ocean observations. There's a program focused on kind of fundamental process understanding of the climate system, adaptation issues in terms of long-term climate change. So we kind of run the gamut from short climate timescales to long climate timescales, and from physical science to building readiness for communities to utilize information that NOAA produces, for example. So we issue this annual call for proposals, and in our particular programs area, we solicit improvements to modeling systems, and this can be both research models as well as operational forecast systems. So we're principally focused on the operational side, on the climate forecast system, that type of timescale, seasonal climate prediction. We also fund research on analysis, so this is really in terms of reanalysis, which is, many of you may know, reanalysis data sets are very important. Homogeneous description of historical climate conditions, basically ingest as many climate observations as we have through a model and then produce a coherent view of the historical climate. And then predictions, so this is both in terms of improving prediction systems, but also in terms of developing and transitioning new prediction products over in operations. And then projections, so longer term climate change, which is a little less relevant, I think, to today. So we work primarily through this competitive process. That's how all of our funding is distributed. We don't fund things non-competitively in the program, and we basically rotate through different topics. So we'll typically fund 3-year proposals, although in the area of transition we fund 2-year proposals typically within our climate testbed. And the climate testbed is the way that we work with NCEP on transition-ready projects. Okay, so as the slide says, our portfolio is focused on developing, testing, and transitioning various research projects into operations, and we're focused on timescales of week 3 and beyond, so sub-seasonal and longer. In the operational forecast context, that's really looking at sub-seasonal out to interannual timescales. we do have some other transition projects which are not necessarily operational, but they may be like applied transitions. They're not going to sit at NSET, but they may sit elsewhere. And we kind of consider even reports that are produced by our PIs or by the program to be, transition products. They're now a product that's available to the public. So we kind of think we have a broad array of different types of transition activities that we engage with across our portfolio. And in the context of prediction, what we're really looking to do is serve NOAA's larger mission goals to improve prediction products and the skill of forecasts on various timescales from subseasonal to longer, and to do this through and training the external research community and getting the external research community to work with NOAA scientists and forecasters. And I'll also mention that we our activities work in support of the National Earth System Prediction Capability. Jessie's here in the room. She's involved with National ESPC on the NOAA side, and it's a multi-agency effort to improve the nation's capability to do forecasts on a variety of timescales, I think, including weather timescales, but also extending out to decadal timescales. So in particular, what we're going to talk about today is this effort to build and experiment with multi-model ensembles. And so those are just what the nomenclature sounds like. It's taking multiple different forecast systems or models and producing coordinated ensembles to improve predictions. And we'll start out, Heather will start out by talking about the North American multi-model ensemble, which is really aimed at seasonal timescales. And then I'll talk a little bit about a new experiment we're doing called Sub-X, the subseasonal experiment, which has just started about a month ago, and based off new funding from the MAP program and collaborators. And that's targeting the subseasonal timescale. So the reason we've done this is because there's a lot of literature out there that has demonstrated that even doing something as simple as just an average of multiple models can produce a more skillful forecast in many cases. So the simple average will often be, in some cases, it ends up being more skillful than any of the individual models that compose the average. But on the large part, this average of all of the model components in a multi-model system tend to be either the most skillful or one of the most skillful expressions of prediction for that system. So it's really a simple finding, but essentially some of the orthogonality of the individual modeling systems can be canceled out or complemented by the other models, and this ends up resulting in a more skillful prediction. So there's a feeling that even though multi-model ensembles require a really large amount of computational effort and data analysis effort, that they're kind of an easy near-term win in terms of being able to move the skill of seasonal forecasting forward to some extent. We always base our calls on directions that we see the community taking, so we pay particular attention to things that come out of the National Academies of Science. There was a report in 2010 that covers on the slide here on subseasonal to seasonal or interannual climate prediction and predictability. And one of the 10 recommendations from that report was that multi-model ensemble strategies should be pursued for seasonal timescales. And so we specifically took that input and advice and recommendation and decided to pursue this in a research setting in an operational context. So I think at this point, I'm going to pass it over to Heather, who's going to talk about the North American multi-model ensemble for the next few slides. And then we'll come back to the subseasonal experiment.
Thank you, Dan. Okay, so yeah, I'll take the next few minutes to describe the North American multi-model ensemble, which was an example, I think a consummate example maybe, in our program of a research project that, through the climate testbed, transitioned into operations. So Dan already set this up well. So this is a multi-model ensemble prediction system, and it's comprised of leading operational and research climate models in the United States and Canada, so hence the name North American Multi-Model Ensemble. And this has been developed and demonstrated via the NOAA Climate Testbed, and just recently completed transition to the National Weather Service Climate Prediction Center for use as an operational seasonal prediction tool. So on the bottom here, you can see the timeline of this process. So this began, I'll talk about this in more detail coming up, but it began the idea for this project and the initial work on this project began in FY11. There were a couple of years of further demonstration of this project, and then there was an evaluation of the project in terms of assessing whether it advanced the Weather Service's current capabilities for prediction, whether it could demonstrate a clear improvement. And because that review was favorable, the process began of transitioning the NMME into operations. And we finally consider that to have occurred in FY16 because that's when all of the partners involved in the NMME signed off on a cooperation agreement about how the NMME would function as an operational system and also as a research platform. And then up here you can see an animation. This is produced by Michelle LaRue at the Weather Service Climate Prediction Center just to demonstrate the skill of the NMME models, the various models, and their individual ensemble members to show how well they were able to capture the recent El Nino events. So this is just an example and just kind of demonstrate how many different members there are in this system. So another aspect of this is not only can you take the ensemble mean and get a very good skill, as Dan mentioned, you're also, by using different models, you're getting models with different configurations, and you're exploring more of the phase space of what's possible in your forecast. So you're getting a more reliable system. You're getting a better range. You're more able to capture extremes, and you're kind of you're remedying the problem that you often have with an individual ensemble prediction system where the model is under-dispersive. Okay, so now I'm just going to, because this is a VLab presentation, I know there's interest in the transition process here. I'll go through how we got to the point of NME becoming an operational system. So this is NME phase 1. So in 2011, the MAP program and the NOAA Climate Testbed jointly organized workshops to establish the scope of what became the NMME initiative. So this is what we consider NMME phase 1. And as an outcome of these workshops, the project, there was an NMME project funded in FY 2011. This is a 1-year project. And the goal of this project was to test and optimize the design of a system for seasonal prediction, and with an attempt to demonstrate that the system could actually improve predictions that are currently available to the Climate Prediction System, or Climate Prediction Center, in terms of what operational prediction systems they had available, because it's not enough to simply show the utility of the system. I mean, we need to show that it's actually an improvement over what's currently available to merit its transition into operations. Okay, so there's a bit of a formatting issue here, but the Weather Service immediately, even though this is still a test project in demonstration phase, the part of the project was producing these forecasts in a real-time schedule. That was a really key aspect of this project, showing that these research centers could produce monthly forecasts in a timely way. And because of that part of the system, the Weather Service, CPC, was actually able to use the NME products right away, starting in September of 2011. They were receiving real-time information, and this was being incorporated into CPC forecasts even as early as then. Okay, so then this is just an example of the type of work that was being done in this early period, and actually throughout to the point that NME became operational, and even continues now. So this is just to demonstrate this idea that you do get a skill improvement with the NME versus, for example, the CFS version 2. So that's the operational system that the Climate Prediction Center uses for their forecasts, or it's the main NCEP seasonal prediction system. So what you see on the upper left here is the forecast skill for the CFS version 2, and this is the ranked probability skill scores. This is for a 6.5-month lead forecast for sea surface temperature. And so this is skill, not actually the sea surface temperature. So where you see the warmer colors, that's where you have the most skill. So you can see areas of red, a lot of red in the kind of the tropics, some areas of blue. But if you compare that to the NMME, you see on the whole, you see an increase in skill for SST relative to what is available for the CFS. So this is just one of the types of many different evaluations that the NMME went through in comparison to the CFS. Okay, so the phase 2 project. So after this development phase in phase 1 that I mentioned, this the NMME entered a 2-year demonstration phase. So this is a project funded for FY 2012 and 2013. And whereas the initial project was supported just by the NOMAP program, this project received support from DOE, from NASA, and NSF as well. So this is truly becoming a multi-agency, interagency effort. During NMME development, throughout this period, in addition to the forecast applications that CPC was using, the community began to use this research, not just the participating members, but the data became available to serve as a basis for a variety of projects related to predictability studies and prediction. Because part of this NMME project is that each model that participates is required to produce a hindcast database. So you have all the hindcasts, reforecasts, and you have the real-time forecast. So because of that, it really provides an unprecedented database that can be mined for research on seasonal predictions and predictability. Okay, so the final phase here is NMME operations, getting into operations. So 14, as part of the NOAA climate testbed process, there was the need to then review, the project's ended, and so now it needs to be established whether the NMME should be transitioned into operations. Of course, it's not a guarantee that this will occur, but the review found that based on NCEP's metrics, the NMME did lead to a systematic improvement in what was available, so the system was ready to be transitioned. And following review, the real-time predictions were formally incorporated into the Weather Service Operational Production Suite, and the transition was finally completed in May 2016 when we got the last signature from all of the partners to consider this, or on the cooperation agreement that I had mentioned. So these just are some examples of products that are produced by CPC in real time operationally. This is the website where you can find these types of products. I just want to also note that we, since this was kind of in concert with the NMME becoming operational officially in May 2016, and the following month we had a webinar that just featured talks related to the NMME, and those dealt with applications, work that came out of the NMME data set, as well as more fundamental research on predictability and uses for operations. So I encourage you to visit our website if you're interested in more information on those various projects and applications of the data set. Okay, so I want to stress the dual purpose of the operational NMME. So that there are operational centers involved, NCEP and Environment Canada, and so they have access to the NMME, so this is a way for them to improve their capabilities to predict or to issue or to have skillful seasonal forecasts. The other key thing is that this is a mechanism to enable research on prediction modeling, as I've mentioned, on NMME data. So the operational NMME benefits operational centers. They received improved data, but the research centers involved, such as GFDL, University of Miami is involved, using the NCAR model. They're able to test their models in an operational environment, which is really valuable to informing future model development. They actually can see how their models do against operational models, against other research models, and make. Okay, so these are the actual models that are in the NMME Phase 2 version 1, which is the official operational system. So you can see the various organizations that are involved and the models, which are a mix of operational and research models. So this is NCEP's model, CFS version 2, GFDL's 4 model, NASA GMAO's GEOS 5 model. Environment Canada has 2 operational models that they contribute. And then NCAR CESM 1 is contributed, and then the University of Miami uses CCSM 4. And this is run through the University of Miami, but also an NCAR model. Okay, and I've mentioned the cooperative agreement that was finally signed. I've mentioned it a few times now. These are actually the partners that signed off on this agreement. So this is signed and agreed upon by NCEP, by OER, both our office, CPO, as well as GFDL, Environment Canada, NASA Goddard, UCAR on behalf of NCAR, and the University of Miami. Okay, so the terms of operation. So this cooperation agreement establishes terms of operation with, as I mentioned, the dual purpose for both operational seasonal forecasts to enhance the capability of operational centers, but also for research. And this cooperation agreement covers the period August 1st, 2015 through July 31st, 2018. So this is co-sponsored, as I mentioned, by both operational and research institutions, and there are a variety of metrics that are used to ensure that both the operational and research requirements are being met. So this is a formal process of making this an operational system, is that for it to continue to be an operational system, the NMME needs to continue to meet or be evaluated favorably in terms of the metrics that are agreed upon, and which I'll talk more about now. So for operational service requirements, there are metrics that CPC has required. So there's a requirement of timeliness. So require a 99% on-time product delivery. So forecasts are due from the different centers into CPC by 5 p.m. Eastern Time on the 6th of every month. Forecasts are then processed overnight, and graphics and data are posted on the CPC website on the 7th and 8th. So there's this operational service requirement, but then there's also ongoing evaluation of the NMME products. So we're looking at physical variables, temperature, precipitation, but also the skill of the NMME in producing or predicting climate phenomena like ENSO, evaluated based on standard NCEP skill metrics. And these are just examples of what CPC produces, the kind of graphics they produce to compare the NMME against its individual models, which include the CFS, just to assess skill. Okay, and then there's a whole variety of ways that CPC is integrated, or that NMME is integrated into CPC's activities. This is just an example. There's a large number of products produced by the International Desk. These are a couple of real-time products produced from the NMME that are used to inform the activities of this desk. And I'll keep moving just in the interest of time. So the other aspect of the terms of agreement from this is that there's a real-time data archive. These are the links where this data can be found. These data can be found. There are 8 real-time monthly fields and monthly hindcasts. And then there are real-time NMME forecast and verification products for temperature, to-meter temperature, and precipitation. In terms of hindcasts, these are all the different variables and levels where you can access this data, and available at these 2 links here. And then I think this is the last slide of the section, or close to the last slide of the section. This is just to highlight the research application. So a key aspect of this, of NMME, is not just the operational contribution or the forecast aspect of it, but what it provides to the research community in terms of an unprecedented data set. It's a gigantic data base. It's growing continuously. So this is supporting all kinds of work, and I'm just highlighting some work here. The Weather Service has their own NMME team, their internal team that's evaluating what's produced from NMME. And MAP has recently funded a set of projects that look at, that use the NMME to evaluate different features, events like sun and stratospheric warming events, atmospheric river prediction, applications for predicting excessive heat, tools for water resource management, and then exploring optimal multi-model combinations with the NMME models, the individual models. Okay, so now I will turn it over to Dan.
Okay, thanks, Heather. So I mentioned in the beginning that based on the success that we had seen with the NMME, we started naturally thinking about whether something like that could be done at subseasonal timescales. That was one of our motivators. I'll talk about a number of other motivators for this new experiment that we funded. But basically, starting this year, as I mentioned, we funded a new climate testbed project, which is called SubX, the Subseasonal Experiment. And it's focused on doing a multi-model ensemble prediction experiment on subseasonal timescales, so designing a system optimally to target week 3 and beyond into short seasonal timescales. So the subseasonal timescale is of course something that's a very significant focus at NOAA. Currently, the White House is even very interested in predictions on subseasonal timescales. We have, of course, a weather community that's been very good and focused on going out to week 2 with predictions, and a seasonal community that kind of picks up the ball around week 3, 4, but really targets months and seasonal and intra-annual forecasting. But there's definitely this gap at the week 3, 4 timescale between that short climate timescale and the longer weather timescale. And so there's this need that the agency has very clearly identified, and I think also a significant opportunity at the week 3, 4 timescale to see what we can provide. And there are a lot of actionable infrastructure decisions and other decisions that are made on these timescales where having improved information could be very valuable to the broad public and decision makers. So a number of points of motivation for why we did this experiment. First of all, in the research community, there is a subseasonal to seasonal experiment that's ongoing in the WWRP-WCRP, this subseasonal to seasonal prediction project. And what this is doing essentially is arranging the forecast data from operational forecast providers around the world into a database. So it's basically whatever way they run their model, they're collecting that data into a database that the research community can use to do prediction and predictability research on these timescales. It's not real time. I think it's lagged to some extent from real time, but it is a way to analyze the operational models for predictability and prediction skill. So there's definitely this context internationally of an interest in this area. We have seen, so historically the MAP program in CPO has been very strong in the seasonal timescale prediction. And this goes way back in CPO for really decades that we've invested seasonal timescales. And even before our program started explicitly investing in and soliciting proposals that have some subseasonal focus, we had seen our seasonal focused proposals starting to dip down into these shorter and shorter timescales as really a natural extension, I think, of the work that that community was already engaged with. That we've long funded research on the MJO, and the MJO is a natural source of predictability on subseasonal timescales. We've long funded research on stratospheric variability and how that influences the troposphere, and that has a natural predictability source on subseasonal timescales. We've long invested in land surface modeling and understanding land surface processes, which have a significant impact and are a source of predictability on subseasonal timescales. So there's kind of this natural movement towards shorter timescales in the seasonal research community that we had seen just through our proposal process. CPC has new subseasonal product requirements, so they just introduced an operational experimental week 3 to 4 temperature and precipitation outlook that actually was supported in development by our program. And so there's more development there. We want to make that a higher quality product, improve the skill of that. So having new inputs to producing that product will be very useful in the operational context. I've already mentioned the agency and the agency's increasing focus on subseasonal timescales, including focus at the White House level on this. And then from a scientific perspective, Heather mentioned that there, the NMME experiment is a really nice operational, research operations experiment, but it's also a nice operational research example. And a really robust way in which the research community can engage in an operational context, because it's created this very valuable data set that can be used widely. When you go and look at papers that are being published on NMME, there are, of course, PIs that we're funding who are publishing using the data set, but it's been kind of amazing to see some of the really random uses that people are making of the NMME data just because it lives in the public domain now. However, this data set is not adequate. The NMME data set is not adequate for doing subseasonal investigation. It only has one initialization per month. There is daily data, but it's really not adequate. Some investigators have started using it to do subseasonal work, but it was clear that we need a real-time data set and a HICAS data set that is really targeted at subseasonal timescales to do meaningful work at those timescales. And then very briefly, I'll just mention this new report from the National Academies of Science, which is on the right. This report came out long after we had issued our call for proposals. However, it did have a number of conclusions in here which supported the direction that we've taken in the program. of soliciting this subseasonal multi-model ensemble system. I have a few quotes in bullet form there, which I won't go through. So the first step to doing this was to draft an experiment protocol and kind of hear from the community where the community is on subseasonal prediction and on ensemble prediction on subseasonal timescales. So we held this workshop in March of 2015 out at the NCWCP in College Park, and a group of the attendees at this workshop discussed what fundamental elements you would want to have in a protocol for doing a subseasonal multi-model ensemble prediction experiment. And so some of these elements are listed on the right. The reforecast period that they landed on was 1999 to 2015. They felt that each model that would participate should have at least 4 ensemble members, that the forecast should extend to at least 30 days in length and preferably 45 days or longer, that there should be an initialization of each model at least once per week. Of course, that initialization should be coordinated in time. That all of the relevant components should be initialized. So if you're talking about a coupled model or an Earth system model, initializing all of the components, land, ocean, atmosphere, et cetera, sea ice. If it's just a weather model or a weather ensemble system, initializing the atmosphere or land forcing or the ocean forcing in some way. That the forecast and reforecast data should be sent through central operations at NCEP. That output should be on a common 1-by-1 degree grid. So that is not the resolution the models are being run at. I think the NASA model that's participating is running at 1 degree atmosphere, but the Navy model is running at, I think, 35 kilometers in the atmosphere. So it's, runs the gamut in terms of resolution of the models. However, for the research community's use and for forecasting use, it's very useful to have this on a common grid. So they actually specify the grid and where each lat-long line lies and each cell lies, and every center will produce their output for the archive, the public archive on that grid. And then a series of variables according to what's known to be desirable, and I think also used some of the learned experience from the NMME process to think about other variables that the community probably would want on subseasonal timescales for doing predictability research and prediction research. And I'll just mention on that last slide that, for some of you who, maybe know about ensemble forecasting or doing hindcasts, there are compromises here. And these compromises exist because of limited HPC. You want to set the bar low enough that you can get a good number of participants, but I think high enough that you have a scientifically meaningful data set and effort. So, the number of ensemble members, I think everyone agrees that that's fairly low. The reforecast period, I think everyone agrees that that's fairly short. There was some discussion about having more common or more frequent initialization, but ultimately this is a compromise to make this tractable for as many forecast providers as possible. So in the competition, we solicited 2 types of proposals, the first of which was for a modeling system. So this is any center that has a model that they would like to participate, or any research group for that matter, could submit their system, and they had to demonstrate that it captures modes of variability and predictability sources that are important on this time scale, and some feasibility to be able to initialize and participate in real time in the experiment. And then a core team to coordinate. And this core team is really critical because they'll bring together all of the forecast inputs that come out of the individual models or other contributions, and think about new products, new ways to ensemble or do bias correction, also supporting the platform for data sharing, so the way that the hindcast data will get out to the community that's part of this proposal. So this really brings the whole experiment together and leads it. And we did require, for the transition interested folks on this webinar, we did require transition plans that are responsive to the NAO on transition, which came out, which was revised last year. And so we designed these transition plan templates that collected all of the information that's necessary to be responsive to the NAO. And also have them signed over on the operational side and the research side. So we went through the whole kind of process with that. So the results of the competition, I'm happy to say that all the awards have been made and accepted at this point. So we can actually, the first time I've actually talked about this in public, who's been funded. So we have a core team. We funded 5 proposals, one of which was this core team. It involves University of Miami, George Mason, Columbia, Florida International Universities, and also Environment Canada and CPC. and Ben Kerman is leading it. He also is the lead of the NMME experiment. And then 4 other proposals, which brings in the GEFS and extends that out in time. The GEOS-5 system from NASA, which also participates in NMME, CCSM-4, which also participates in NMME, and then the Navy Earth System model. So overall, we have 6 modeling systems. I just listed 4 of them. CFS-V2 also participates. Of course, they're running operational forecasts, so that data is brought in via the core proposal, and then the Environment Canada data is brought in through the core proposal. They're receiving a little bit of funding from our program to do that. And as with NMME, we do have co-support from a number of groups, so Office of Naval Research, the Modeling and Analysis and Predictions program over at NASA, and also the Weather Service STI Global Modeling Program. So we're really happy about that, that they really helped make this significant effort possible. We're very happy to see this large number of models participating.
Are the Canadians in?
I'm sorry?
Are the Canadians in? You don't list them there.
Oh, involved in funding?
No,
This is the Environment Canada.
Oh, sorry.
Yeah, no, that's okay. Yeah. Shortest acronym, so it's easy to miss.
Surely they support it with funding.
Internal funding. In terms of actual support for the proposals, right. They're not kicking in support in that respect.
They're not sending it over the border, but sending it within the border.
Right, that's right. Right. And like I said, we are actually sending an award up to EC starting next year for their participation. So we're actually funding part of their participation. As with the NCEP component, EC runs a seasonal forecast system, so it's part of their operational workflow to produce these kinds of forecasts. But it does require some hewing to the requirements of the project, which is why we're supporting that. So this is my last slide on SubX. I think we're very happy with how this turned out. It did require a lot of legwork on our part to get everyone to apply and encourage broad participation and whatnot. But ultimately, I think the group of models that has been supported is really exciting. Each of these groups also that's participating has a very different focus. So like the NASA group is really interested in some of the land surface questions and land surface predictability from soil moisture memory, et cetera. The Navy group is very interested in their high-resolution ocean model, which they're going to be running at 9 kilometers, and the impact of mesoscale ocean variability on subseasonal prediction skills. So that's kind of an interesting research question. We have the GEFS, so we have a system that's been honed for initialized weather prediction that's participating, and then research models like the CCSM-4, and then the operational climate forecast system and the operational Environment Canada model. So it's a really nice diversity of models. It kind of covers a very nice range of the types of prediction models and research systems that are out there. So we're very excited about that. Heather's leading this new task force, subseasonal to seasonal prediction task force, just kicked off last week. Heather had a call last year in this area, separate from this climate testbed competition, so it's more upstream predictability, prediction development work. But the SubX is really relevant to that, so there's some cross-fertilization there in the SubX TIs. Some of them are going to participate in the seasonal prediction task force, the subseasonal to seasonal prediction task force. I mentioned our CTB projects are 2 years long, so this is a pretty aggressive time scale. In the first year, they're roughly going to be producing their hindcast data set. And then in the second year, they're going to be doing real-time prediction with the systems once the hindcasts are produced, and they can calibrate the forecast and be answering some of those questions about bias correction and doing evaluations. There's, for example, a drought component to the lead proposal, the core proposal. So there are a lot of interesting sort of procedural logistical questions here that are answered, but also a lot of interesting science questions which come along with this. I think that's really critical both in NMME and SubX to, fully in training the research community. These people are not just running models, they're actually able to investigate and look into really interesting and timely science questions too with this data set. So we find that as a very healthy way of creating a transition type project that really engages the external research community, and also has these lasting benefits for the research community because this hindcast data set will endure. And after the second year, we'll have a review with NCEP managers, and we'll discuss the results from these projects It's going to be very critical during the real-time period, as Heather mentioned, to have that 99% real-time, up. I mean, these predictions have to get into the system in real time, or else it's going to be very hard for NCEP to say that they approve of a particular model participating if it, misses a number of initializations or doesn't provide forecast data. And that has happened with NMME. So, it's very important to show reliability for the transition question. But we'll see, are the models producing useful predictive skill at this time scale? Are they contributing successfully to the system? And then make that call on whether the whole system transfers or whether elements of it transfer into operations. And I just wanted to really wrap this up because I know that we've talked about this a little bit over the last year with folks, and there is an impression that that SubX is just sort of this kind of add-on to NMME, and there are some similar individuals involved, but this was solicited through an open competitive process. It has a different protocol. We did certain elements of this differently than how we did it for NMME, and so it's really not an extension. It's an independent experiment that shares some similarities and some personnel, but it's its own thing, which will be considered separately from NMME. So this is a summary, just big points. We talked about NMME, talked about SubX. As I mentioned, these have been really great ways to engage the research community with NOAA in a transition context. They've been done through this climate test bed, which is the primary way we work with NCEP in a transition framework. And we're happy to take questions. I think that's about it.
All right. Thank you. I just say, wow, this is quite impressive.
Yeah. Oh, that's good.
So remind everyone, we're on open mic here in the room, so please, no side conversations. So let me start off. I mean, this just is really, really impressive. So in 5 years, it's audacious. I mean, you've got all these multiple players, you've got operations, you've got research, you've got agreements, it's almost like how did it happen? It's like a miracle. So let me ask the two of you.
That's your question.
Not my question is coming. So I give both of you a chance. What would each of you attribute? Why was this successful? What's the most important thing that this became operational? I'll start with Heather first.
Well, I came to this late, so I've been in MAP for 2 years, so I was not there for the whole development. But I guess I'd be more interested to see what Dan says. But from what I witnessed, I think it's been the close partnership, kind of ongoing work between the MAP director, our impact director, Anarita Mariotti, and the climate testbed director at the time, Jin Wang, in getting, really pushing this forward. Kind of was a desire on both sides, as far as I understand, and a lot of organization. But I think, I'll let Dan fill this one because I think he's better. He has a full, or a longer period of.
Yeah, I mean, I don't know how much I suppose, it has not been easy. So if it looked easy, it has not been easy at all. I mean, we've had, it's been a lot of work, for example, to get the agreement signed over the last year. We had clearance from a community panel that this thing should be operational in 2014, and it took a couple years to actually make that jump, even though the system had really been tested at that point. So, it certainly wasn't easy. I mean, there was a lot of work with the agency partners. There was a lot of thought that had to go into, we have operational models like CFS, which are just running real time. They're going to keep doing that because that's part of the operational mission. But then, it's not like NCEP and the Weather Service are not built to accept a model like CCSM4 being run primarily on research computing at NOAA. I mean, that's a very potentially unreliable thing to take into the operational cycle.
Definitely.
So it did take a lot of, I think, work and discussion between all of the partners to agree to continue to have these systems in. And I think there's still concern on the operational side.
So it's still honeymoon phase.
That. Well, and I mean, it's a 3-year agreement, so I think you have to continue to show reliability in that time period to continue living.
Yeah, so 2 things to follow on with that. One is, the OIR labs, at least in some cases, hadn't, set up to do this. So the fact that they're exploring a new way of trying to participate in NOAA missions that they weren't necessarily involved in has been very interesting to watch. The other piece of that is while they're dedicating a certain amount of resources to continuing to turn this thing out on time and so on and so forth, they might have been doing it anyways, but they wouldn't have been doing it in this particular way and sending it and so forth and so on and following certain protocols necessarily that might be inconvenient for them. So I think that needs to be acknowledged, that there's been a lot of progress in recognizing the value of that from a research institution that didn't consider that before. I think the other one I wonder about is, so what happens when, it happens with operational systems too. You miss the delivery, a model, a set doesn't show up. What happens? You just put it out a day late. What's your fallback plan? There always is a fallback plan for operations. Sometimes it's just you skip it. One is you just like leave it out. One is you do it late. What do you do?
Can I take that? Yeah. So the reliability comes down to, I think this is something that took a while to work out. It actually is, so NME is considered a distributed system, so the operational aspect is the products that are produced. And technically the products can be produced with just the operational contribution.
Correct.
So that is the basis for it. If,
so the plan is leave it out and it doesn't show up.
It can leave, it's left out, and that does happen. Okay. That's, if models are not get in on time, they're left out. So the products are always available, but, the individual systems still need to make sure their data, are arriving.
Like as an extension of that, for the operational climate, I haven't worked at CPC, so I don't know, but what I imagine is that, they have a bunch of different inputs to doing their operational forecasting. Statistical inputs, they have dynamical inputs, and they put all this stuff up and kind of look at it, and then they can make determinations on above, below, probabilities for temperature, precip, et cetera. So, having the most information possible is useful. If a model drops out, they still have other things that they can rely on.
What I'm getting at is there is a standard procedure for what you do in that case.
Yeah,
because it does happen.
It goes out.
And so it goes out, and you don't wait. In some cases, there's a tolerance for how late you can make it. But so that you noted, I guess, on the operational site and move along. The other one, I wonder, do you see a market drop in skill when one of the models, is missing?
That's a little, I don't think I could answer that. Yeah.
Probably one model missing wouldn't make, in the grand.
I'm sure it depends on the situation.
Yeah.
I don't know if there's been a really concerted analysis of that. And I don't know. Dave, I don't see Dave on the line, but I don't know that they've missed too many forecasts.
I don't think.
In terms of the provision of the data.
So actually, there's a review, the one-year review of this project, or kind of update, is going to be happening in October, and we're going to be hearing about, from CPC on these reliability statistics, and so we'll kind of get a status update at that point, and I probably would really answer that question.
Someone I assume is tracking its skill at.
Yeah, that's a requirement that's laid out in our agreement.
And when you see something like that, and you note, what the reason might have been for a skill variation.
Can I add one more thing just in response to your question?
Yeah,
if that's okay. So the other thing that I would mention is that I think, so actually the workshop that Heather was talking about for NMME, that was on like my second day in the job, so I had really no idea what was going on. But I think, the bar was set kind of low in the beginning. So it was an ensemble of opportunity is how we called it in the beginning. You had CFS, you had some other models that were kind of ready to participate. And so we started from a low bar. And then I think, and Heather got to this, that we had like great people involved originally. Ben was involved from the start. He really was able to drive the research community, the organizational element. Wayne Higgins was at CPC at that point, and he was very receptive to this. Jin Huang was at Climate Test. No, she wasn't there. Fiona Horsfall, I think, was over at Climate Test Bed at that point.
The webinar.
Yeah, so maybe she can remind me of where she was in 2010. But we had people, we had just a great group and an opportunity to do this, and I think it was really supportive. People have been impressed by what's come out of it. The operational forecasters have given it good feedback, so it kind of grew organically over the last few years. I think the bar is a little bit higher maybe for sub-X this time in terms of the investment, because ultimately with multi-model ensemble systems, I think you're hoping that like the CFS will eventually just blow everything out of the water. We don't have to run 6 models every month in order to, get these predictions. I mean, that's a really huge effort, but at the moment it acts still. So.
Very good, thanks. John, we have a question online.
Yeah, folks at Eastern Region Headquarters have a question for us.
Go ahead. Ken or whoever's there?
Yeah, this is Ken Johnson, Eastern Region SSD. Yeah, I got maybe about 3 questions if I could.
Go ahead.
First question relates to NMME. You probably mentioned this and maybe I missed it, but where is this system running? I'm getting the impression where you're talking about 99% uptime, that it's not really being run on the weather service hardware.
Right. So the individual centers run it and then send the data, and that's what the reliability refers to. They run the model and then, right. So it's the reliability refers to the products that are produced from the NMME. Okay. So the other model running at Miami.
And also to the data arriving on time.
And data arriving, yeah, you're right. Yep.
Okay, thank you. Another question, I think it was on your 3rd slide where you had some of the advantages of running a multi-model ensemble, and one of the bullets talked about averaging predictions improves skill in terms of canceling out the biases, and I don't think anybody argues about that. But I'm wondering if in the averaging process, if there's any smoothing out of spatial and temporal detail, if that's at all a consideration in the skill. I'm
not sure if I can speak to what the thought process for, how this came about, but I guess I can give my perspective is that since this is a seasonal application, looking for these kind of large-scale signals, so I think the canceling out of details or the smearing effect that you get from this type of, flat compositing or taking the mean, that's not essential for the time scale, the relatively coarse time scale that you're looking at. You're looking at, producing outlooks. So I think the benefit overall, yeah, you're losing information, but of course, so I should say the NMME is not just producing, the multi-model ensemble mean, and that's it. That you also can see the individual models and what's produced by those models, and their individual ensemble members exist too. So you are able to see what details are being missed by the averaging process.
Yeah, and that's the baseline. I mean, I think there's a lot of research and questions about how to take advantage of, like Heather was saying when she was showing that animation, like you have so many different realizations now of the future because of the model diversity and because of the initialization diversity, that you can really start to think about how to take advantage of that for looking at extremes, or for example, like the ENSO non-impacts this past winter. Like, did that outcome live within the probability that was produced by NMME at some lead time from DJF this past winter?
Right.
Was that in there? And and maybe some of the models caught that. Why did they catch that? Is there something about the model? I mean, there's a lot of interesting questions when you get away from just the ensemble average that I think the research community is asking for this data set.
Right.
Okay. One last question, kind of a follow-up maybe to Steve Smith's question. This has been a relatively successful example of going from research to operations, and done kind of in a 5-year time frame. And I was wondering if, I guess what I'll call the R2O landscape now, I was wondering if you were to start this project all over again now in 2016, would it be easier or more difficult to accomplish starting with the research and going to the operations?
I think, well, I guess I would answer that by saying that we used the lessons learned in terms of the way we approached the sub-X solicitation in that project. And so I do think it would be easier now. I think we have a better idea when you're in the transition space of how to set requirements and expectations early that we didn't necessarily do with NMME in as disciplined a way as we've done it with sub-X. We built it in kind of a community manner. The NMME we built in a community manner, starting out with this community meeting, and it kind of emerged organically, and then there was a competitive funding call. But this time, like, we really, I think we're very disciplined about thinking about where the bar is going to be ultimately for this system, and just taking some of the simple lessons learned from before that, like, for example, in our call, we had the individual systems come in with their own proposals. They had to pass some sort of bar of performance before we even decided to fund them. And, a scientific review committee looked at that and said, yeah, this model seems like it'll perform well. This model is a little bit questionable in terms of what it's going to provide. So, I think sub-X, so far, it seems like we learned lessons in that because there are some similarities there that it is better in 2016 than it was in 2010.
Okay, thank you.
And in some sense, it's easier in climate because they only have to run this stuff once a month. Is that what they?
For NMME, yeah.
Right.
But not if you're CFSV2. I mean, they run that.
They run it.
4
Well,
times
of
a
course,
day.
but they were going to do that anyway. So my point is, if you're going to try to do this for a 24-hour forecast, it would be more difficult.
Yes.
Oh, absolutely. Right.
Definitely.
I just had a brief question, and I think part of the comment is one of the ways you've been successful has been to leverage already existing models and bring them together. What would you perceive? What do you foresee as a paradigm for model improvements within the ensemble? You know, of course, we don't want to freeze the system in time. We want to leave some flexibility for improvement. What do you envisage for that?
Can you think that?
Maybe I'll preface what I was going to say by saying that I think there's a lot of opportunity for the multi-model approach here for climate or for seasonal and even subseasonal that is not necessarily true for weather. I mean, I think, you know, climate modeling is relatively, you know, it lags quite a bit behind weather model. I mean, weather, you know, numerical weather prediction is really far ahead of, you know, this is a relatively new area, so you can get a lot of leverage and it's a worthwhile investment to combine models in this way. But that said, the way so the idea is, so you're testing these models individually in an operational system, and then the model developers can look at performance, and it provides a way for them to make improvements to their models as they go forward. I think, you know, Dan mentioned this earlier, I mean, the goal, ideally, and I know NOAA, this is very important for NOAA, especially on the weather time frame, is to move towards, you know, maybe not a single model, but to really kind of narrow down the number of models that you're working with and really try to have the whole community, even beyond NOAA, you know, kind of invested in making model improvements and not having, you know, efforts that are kind of separate or unaware of each other. So I don't think this is counter to that at all. Actually, I think this is, Dan also mentioned this too, especially for sub-X. We kind of envision this as a short-term fix. I mean, we're hoping, you know, this isn't a matter of a year or two. There could be a new tool for CPC that is very helpful, hopefully, for their week-3 forecasts, if it, you know, it proves to be. We're optimistic, but the longer range plan is for model development, better physics, and all these other issues. This is kind of a shorter term fix, and then there's opportunities within that to explore research on ways to combine the different systems, you know, multi-model combinations, and to kind of, there's really refined ways. I mean, that's a whole new research area too. It's how to make the most of these multi-model ensembles, get the most skill out of them. So yeah.
There's also there are also requirements, and I don't remember exactly how they're phrased in the operational agreement for, you know, when centers want to update their model, what they have to do. They have to do the hindcast with the new model, for example. So, you know, there's an acknowledgement of that in the agreement about how to carry that out. But I mean, that's a heavy demand. That's
actually a big point. I forgot to mention, that the NMME isn't supposed to be a static. You know, this is version 1. And it's expected that, you know, model centers can produce their, you know, next version of their model, and that will be version, you know, part of version 2 NMME, and then that will be, as Dan said.
And that's happened, like,
it's happened for a couple of years.
We've got a question from, or Wayne Higgins would like to ask a question. Wayne, you there?
Yeah, I'm here. Can you hear me?
Yeah, a little bit distorted, so maybe back off the mic a bit.
Okay, how's that?
That's better.
So I just wanted to follow up on the earlier discussion about, you know, what's changed in the last 5 years that might make the NMME easier to implement today. First, I guess I'll preface it by saying even before I was the director at CPC, I was actually the first director of the climate testbed way back when, and we were even talking about the NMME at that point. So this project really has had quite a history, and it does take a village. But as to what's really changed today, one other thing I'd really like to emphasize is the very strong and getting closer relationship that we have through the OAR Weather Service Level Agreement, which has not only, you know, ongoing research projects, but also projects which you can call gap projects based on requirements that aren't being met. So I think that in particular is a very key piece of the puzzle that, for example, if we get further down the way and sub-X, needs some components filled that we're not able to get at through the competitive grants process, that we actually have an opportunity there to accelerate it. So I just really wanted to say that I think that the service level agreements between the line offices have emerged in a way that I think can make these things more effective.
Thank you, Wayne. Appreciate that. So we're at the top of the hour, a little bit past actually, so we're going to have to wrap it up. I want to thank Dan and Heather for just really excellent presentation. Really appreciate the attention to the research ops transition focus. This is really a unique one. I'll be talking to you more later. And to remind everyone, again, shortly after this, we'll upload the recording to the VLabForum website so you can share that with your colleagues or whoever. Reminder, coming up October, we've got a talk by Phil Schumacher on relating precipitation types to maximum temperature aloft. And then in November, the aviation forecast verification tool, Tabitha Huntsman will be presenting that. So thanks, everyone, and we will see you in October.